So now you know how to do confidence intervals. So you should be able to do confidence intervals for proportion percent. All right, remember percent's just proportion with one extra step. And you should be able to do confidence intervals for mean. So what we're going to do now is we're going to start chapter 8 on hypothesis testing. Now, we're just going to do very simple, just kind of really introduce you to hypothesis testing. A lot of statistics classes start with hypothesis testing. So a lot of your disciplines had you take this whole course just to kind of get you to this point. To get all the background information to kind of start with hypothesis testing. So they can kind of take it from there in your discipline areas. So let me kind of find my PowerPoint and share that with you, and we will get started. All right, so it's the beginning of chapter 8 on hypothesis testing. So first, let's make sure that we both agree on what a hypothesis is, okay? Hypothesis is just a claim about something. So it's a claim about the property of a population. So it might be, I think that more than 30% of people have blue eyes. Or it might be, I think that the average ACT score is less than 25. Or it might be, I think more people make better scores on a reading test if they're taught with phonics. So it's just a claim about something, about a population characteristic, okay? So a hypothesis test is a procedure to test the claim about that property. So we're going to do proportion percent first, and then we're going to move into mean. But this video is just kind of to introduce you to the whole idea of testing hypotheses. Now, I made a little chart. It's really better if I kind of talk you through it. But the chart's all filled in because, you know, that's the way it kind of has to work. So a hypothesis, a claim, is really either true or it's false. It's right or it's wrong. Okay, now you're going to have two possibilities when you're testing these hypotheses. Either you're going to reject the hypothesis or you're going to fail to reject the hypothesis. Now, they never say accept. Now, I put accept down here in parentheses, but you'll never write that. It's just for you to kind of help me help you follow the chart, okay? But you're going to say reject or fail to reject. Now, two of these would be correct decision and two of these would be mistakes. If that hypothesis was really true, then you'd want to accept it. You know, you'd want to believe it and act like it's true. That'd be a good decision on your part. If that hypothesis is really false, if that claim is false, then you want to reject that claim. You want to throw it out. So again, we want to accept or fail to reject things that are true, and we want to reject things that are false. Those are good decisions. Now, these two are mistakes. Your book calls them errors. Now, they distinguish between them by calling this one a type 1 and this one a type 2. Now, look what a type 1 error is. The hypothesis is really false, but see, you buy it. You accept it. Well, see, that's a mistake. That's a type 1 error, a type 1 mistake. A type 2 error, the claim is really true, but you reject it. You don't buy it. Well, that's a mistake. Now, sometimes in some situations, a type 2 error is worse, and in some situations, a type 1 error is worse. So we're going to kind of look at an example of both to kind of show you what I mean. All right, here's your claim. Now, this is kind of a silly one, but it kind of makes my point. All right, I've always wanted to go skydiving. That's like a for real thing, so one day I will. So, you know, my hypothesis is going to be that my parachute's going to open. So that's the claim. My parachute will open. Well, either it really will, it's true, or it really won't, it's false. And depending on what I believe will determine my behavior, okay? If that statement really is true, my parachute really will open, then I want to accept it. I'm standing in the plane, I'm in the doorway, the claim is my parachute will open, I believe it, I accept it, so I jump. So I have the thrill of a lifetime. Good choice, good decision. All right, here's another good decision. That statement really is false. That parachute not gonna open. So I'm standing in the doorway of the plane, and the claim is made that your parachute's gonna open, but I reject it, I don't believe it. So I'm not gonna jump. And sure enough, we get down to the bottom, land the plane, open the parachute pack, and it was all tangled up, and I'm like, woo! See, I was right. So we want to accept true things and reject false things. Now, these are mistakes. Now, look what the difference would be in the mistakes. All right, that a type 2 error, that statement really is true. That parachute really is going to open, but I reject it. So if I'm standing in the doorway of that plane and I reject that statement, I don't think it's going to open, I don't jump. So that's a mistake. It was really true, the parachute would open, but I was scared and I didn't jump. So the error there is I missed the thrill of a lifetime. But look at what a type 1 error would be in this situation. That statement's really false. That parachute's not going to open. But I'm standing in the doorway of the airplane and I fail to reject. I accept that statement. I accept that my parachute will open. So if I think my parachute's going to open, I'm going to jump. But it's not going to open. Now think about the consequences of that. Pretty dire. Okay, so I think we can all agree in this situation, death is a little worse than missing the thrill of a lifetime. So in this particular situation, this particular example, a type 1 error is worse than a type 2 error. But look at a different situation, okay? This example deals with the American court system. In America, the person's innocent until proven guilty. So the claim is when the person walks in court, if I'm on the jury, the hypothesis is the person's innocent. Now again, 2 good decisions and 2 mistakes. If that claim really is true, then I want to accept it, then I make a good decision. That person really is innocent, I believe it, so I let them go. All right, this is another correct decision if I'm a juror. That statement really is false, that person's not innocent. And I listen to the evidence and I reject that statement, I'm not buying it. So again, that's a good decision. A guilty person suffers the consequences of his or her actions. So that's the way it's supposed to work. Innocent people go free, guilty people suffer the consequences. Now these are mistakes. Now remember, last time this type 1 error was worse. Look at this situation. What would a type 1 error be? That statement's false, the person's not innocent. But I'm on the jury and I buy the statement. I believe they're innocent. So if I think they're innocent, I'm going to let them go free. So this error, a guilty person goes free. So that's a pretty big mistake. It's a pretty big error. But look at this error, okay? That statement's really true. The person's innocent. But I'm on the jury and I reject it. I don't buy it. So I'm going to vote them, guilty. So this is a worse error. This time a type 2 error is worse. An innocent person is punished. Here, a guilty person is freed. So the American court system is set up supposedly so that we have more type 1 errors than we have type 2 errors. We prefer that a guilty person go free rather than an innocent person go to jail. Now, what's going to happen in this video, I'm going to give you all the steps for hypothesis testing. All right, on the next slide, it's got steps 1 through 6. That's the ones you're going to do for homework tonight. Then next week, we're going to do steps 7 through 10. So what you might want to do on this next slide, my advice would be to freeze the video and copy down these steps and then the steps on the next slide, okay? Because you really want those steps next to you when we go to work a couple of examples in a minute. So here's what's going to happen when you do hypothesis testing. It's going to be a word problem, and you're going to find where it says test the claim that, and you're going to underline what follows it. That's going to be just an English sentence. And you're going to change that English sentence to a mathematical sentence. And when you do that, write the word claim in a parenthesis next to it. If you don't, you're going to get lost next week. So change that English sentence to a mathematical sentence and put the word claim next to it. And make sure that you use population symbols, not sample symbols. So if it says mean, you make sure that you put mu, not x bar. If it says proportion, put p, not p hat. And if it says standard deviation, make sure you put sigma, not S, okay? So you've got one math sentence written down. Then you've got to come up with another math sentence that encompasses all the other possibilities. So suppose your sentence was that the mean was less than 4, okay? What other sentence would encompass all the other possibilities? All right, do you see that you couldn't just put mean is greater than 4? Because if you have one statement say mean is less than 4 and one say mean is greater than 4, what happens if mean equals 4? So you got to be careful. It's got to be one more statement. So if the original was mean is less than 4, my other statement would be mean is greater than or equal to 4, because those 2 statements have to encompass all the possibilities. So that's what it means by number 2. Now, those are your 2 hypotheses, and every problem is going to have 2 hypotheses. And you need both for two different reasons we'll talk about. So one of those is called the null hypothesis, and one's called the alternative hypothesis. Now, how do you know which one's which? The null hypothesis is always the one that's got equals in it. Now, it doesn't have to be just equals. It could be less than equal to. If it's got equals in it, that's the null. And then, of course, the other one that's left over is your alternative. And the reason you need two is this. The null hypothesis is always what you test. And the alternative hypothesis tells you which test to use. Now, some people think that you always test the claim, but you don't. You test the null hypothesis. Sometimes that's the claim, and sometimes it isn't. Okay? Now, you look at the alternative hypothesis. If it has less than, you're going to use something called the left tail test. If it has greater than, you're going to use something called the right tail test. If it has equals, you're going to use something called a two-tailed test. And then you're going to find the significance level. They call it alpha. The most common is 0.05. So if it doesn't say, we default to 0.05. But on a test, I will say what it is. Now, make sure you freeze it and have those written down, because we're going to need those 6 statements in a minute. Now, I went ahead and put these statements. We're going to talk about them more next week, but they should be in your notes. You're going to use the calculator to get a probability, P. Then you're going to compare P, that probability, to alpha, your significance level, okay? So if P is less than alpha or P is equal to alpha, you're going to reject the null, and you're going to write on your paper the words reject the null. If your probability from the calculator, if P is bigger than alpha, that significance level, you're going to fail to reject the null, and you're going to write on your paper fail to reject the null. So I will see one of those phrases written on your paper. And then you're going to look on page 366 in your book, and you're going to use the flow chart there to write your final answer. And you'll see what I mean by that. So make sure those steps are all written in your notes, and then let's go do one, and then let you do some on your own. All right, here's what I mean. So for homework, you're going to kind of be doing these first few steps, okay? So look at one we'll do together and then let you do some. So the claim is that less than 25% of adults use Twitter, okay? So that's the sentence that we're going to change to a mathematical thing. So because it's percent, percent's not mean and percent's not standard deviation, percent is proportion. So what I would do is first, this would be what I would write on my paper, okay? So I would just write down that P is less than 0.25 and then write the word claim in a parenthesis next to it. So that's what that English sentence looks like in a math sentence, less than, less than. Now remember, P's are like, proportions are like probabilities in that they've got to be between 0 and 1. So that's why you wouldn't put P is less than 25, it's got to be 0.25. Now you'd have to come up with some other sentence that encompassed all the other possibilities. So if P is not less than, P would have to be greater than or equal to. So that's how I know to write that second statement down there. So now only these 2 statements are on my paper. Now those are my 2 hypotheses. So one's the null hypothesis and one's the alternative hypothesis. How do I know which is which? Remember, the null has the equals. See, that one doesn't have an equals, but that one does. See, greater than or equal. So that's how I know that this one is my null hypothesis. So that makes that one the alternative. Now, usually I write the words null and alternative, but the book's going to use H sub 0 for null and H sub 1 for alternative. Now, I'm going to warn you that your author, and a lot of statisticians do this, I'm not going to do it, but you're welcome to. When you turn to the back of the book to check your answer, they always turn the null into just equals. Okay, it has to do with the way that the problem, the final answer is worded when they do that. So you may have this written on your paper and the back of the book has that. And I would take either one of those, okay? So that's what I mean by steps like 1 and 2 and 3, okay? Now, you've got to decide which test to use. I told you to look at the alternative hypothesis. So there's my alternative. It's got less than in it. So look at the notes. If it's got less than in the alternative, you have to use something called the left tail test. Now, you have no idea what a left tail test is yet, but you know that you're going to use it. So, and then your alpha, they don't say specifically, so we're going to default to 0.05. Now, I might ask you this, are you testing the claim? Well, the answer on number 1 is no, because you always test the null hypothesis, and that one doesn't happen to be the claim on that problem. Now, what I would do if I were you is I would stop and freeze the video, and then on my own, I would try to do number 2, number 3, and number 4. And then when we go through them real quickly, you can check and see what part you got right and what part you didn't get right. So freeze it and change this to a math sentence. And then write another sentence that encompasses all the other possibilities. Make sure you use population symbols. Then decide which one's your null and which one's your alternative. Remember, your null has equals. Then look at your alternative and decide which test you're going to run, and then write down your significance level. So freeze it and do that, and then join me, and we'll double check the others. Okay? All right, hopefully you did what I asked you to and tried it yourself. All right, I'm going to erase kind of the marks that I made so it's not distracting. Okay, maybe on a good day. Okay, so let's clear that. Maybe. There we go, finally. Okay, so I changed average is null. So that's why I put mu. Now I can't put X bar because it's got to be a population symbol. Is equals 19. So the first thing on my paper was mu equals 19, and I put the word claim in a parenthesis next to it. If you don't put claim in that parenthesis, you're going to get lost next week. All right. So if that statement's not true, then mu must be not equal to 19. So those two statements encompass all the possibilities. Now, how did I know that this one was the null? Because it's got equals in it. Okay. So I labeled my hypotheses. Now I've got to decide which test to run. So I look at the alternative and it says not equal to. So because the alternative says not equal to, I'm going to use something called a two-tailed test. Don't know what that is yet, but I'm going to use it. Okay. And then it doesn't say, so my significance level is going to be 0.05. If it doesn't say, go with that. But on a test, I will tell you, and your book usually tells you. Remember, I might ask you, are you testing the claim? Now, the answer to this one's yes. Why? Because I'm always testing the null, and the null happens to be the claim on this problem. All right, look at this one, majority. Think about majority. Isn't that more than half or more than 50%? Okay, and that's proportion. So that's why I have P is greater than the decimal 0.5. 1/2 is a decimal, or your percent, 50% is a decimal. And that's the word claim. So I wrote that down first. Then if P is not greater than 5/10, it must be less than or equal to 5/10. Okay? Whichever one's got the equals is the null. So that one's got equals. So that one's my null. So the other's my alternative. And then you look at the alternative, decide which test, and it's got greater than. So I'm going to use something called the right tail test. And then again, alpha's my 0.05. Am I testing the claim on this problem? The question and the answer is no, because that claim is not your null hypothesis, and you're always testing the null hypothesis. Now remember, I'm warning you, you have this on your paper, but when you turn to the back of the book, they're always going to change the null to just equals. All right, let's double check that other one and make sure that we did okay on that fourth one, and then look at one more real quick. All right, so here we go. All right. So standard deviation, that's my population symbol for standard deviation. All right, is at least 11 beats per minute. Now remember, at least doesn't mean less than, at least means that number or bigger. So that's why I have greater than or equal to 11, and I put the word claim next to it. If the standard deviation is not greater than or equal to 11, it must be less than 11. Then you've got to label which one's the null and which one's the alternative. So remember, null's got equals, so that's why that one's the null and that one's the alternative. I'll look at the alternative. It's got less than, so because the alternative's got less than, I'm going to use this thing called the left tail test, and alpha is still 0.05. So are you testing the claim on this one? Well, remember, how do you know that? You're testing the null. Since the null happens to be the claim, we are testing the claim. So hopefully you understand that. You always test the null. Sometimes that's the claim, and sometimes it's not. Okay? So let me clear those stray marks again. Now, when it's a word problem, here's what you're going to want to do. You read through the problem and you find where it says test the claim that, and then you underline what follows. So a program was designed to assist people in their ability to stop smoking. Of the 212 patients who were admitted to the program, 140 of them were no longer smoking at the completion of the program. So use the 0.10 significance level to test the claim that at least 70% of patients stop smoking when using the program. So I read it through one time just to get an idea of what it's talking about. Then I go back looking for test the claim that, and I underline it. What I underline is what I turn into my sentence. And remember we just said at least means that number or bigger. So the first thing on my paper that I write down is P is greater than or equal to that number or larger. Now, if P is not greater than or equal to, it's going to be less than. How did I know which one of these was my null? Again, it's always the one with the equals. Okay? How did I know to use a left-tailed test? Because you always look at the alternative hypothesis and because it's got less than. Now, here's the way I used to remember. When it's less than, see how it looks like it's pointing to the left? That's when I use a left-tailed test. Okay? And then my alpha, all right, is 0.10. Why? Because it told me that my significance level was 0.10. So on your homework, what you're going to be doing is you're going to be taking some problems and you're going to be just doing these first few steps. Okay? So let's go back real quick and review, all right, what those steps are. So for homework, it's going to tell you to do the first 5 steps. And then remember what I just said. See, on less than, it looks like it's pointing to the left and you use a left-tailed test. When it's greater than, it looks like it's pointing to the right and you use a right-tailed test. Okay? So try those homework problems and let me know if you have any trouble with them. Now, some of them, you're just going to be setting them up, and then next week, I'm going to show you how to finish them. Okay? So just like I said before, if you're having any trouble, make sure that you're emailing me to get some help. You get just as much help now as you can if you're on campus. So one-on-one Zoom meetings, emailing back and forth, but don't get behind. And you need to still study as if you weren't going to have your notes for your test. Because I don't want you to spend all your time flipping and hunting on your notes rather than actually working the test. So you do need to study and you do need to do all the homework. Okay, see you next time.